Ever wondered how software is developed from start to finish? Well, the secret lies in a structured process called the Software Development Lifecycle, or SDLC for short. The SDLC is the backbone of every software project, providing a roadmap for teams to design, develop, test, deploy, and maintain software products. It's like the recipe that guides a chef from gathering ingredients to serving a finished dish. The SDLC is crucial because it ensures clarity, order, and efficiency in the chaotic world of software development. It breaks down the complex process into manageable phases, allows for precise planning and execution, and helps manage stakeholders' expectations. While the specific methodologies and practices may vary, the SDLC's core essence remains consistent, guiding the journey of a software project from inception to completion. Now, are you ready to dive deeper? Let's explore the phases of the SDLC. The first two steps of the SDLC are requirements analysis and planning. Imagine that you're about to embark on a journey. You wouldn't just start walking without knowing your destination or the route to get there, would you? In the same way, a software development project needs a clear understanding of its objectives and a plan to achieve them. This is where the requirements analysis and planning steps come into play. Let's unpack requirements analysis first. It's all about gathering and scrutinizing information from stakeholders. These stakeholders could be anyone with a vested interest in the project, such as end users, business managers, or technical teams. The goal here is to gain a thorough understanding of what the software needs to do. This involves documenting user needs, functional requirements, and technical specifications. It's like creating a detailed wish list for the software project. Once the wish list is complete, we step into the planning phase. Now, we've got a clear idea of what we're building, but how are we going to build it? That's what we figure out in the planning stage. We define the project scope, set out achievable goals, and allocate a realistic budget. We also establish a timeline and decide on the resources required. It's akin to charting out a roadmap for our journey. But what about risks, you may ask? Absolutely. Risks are an inevitable part of any project. So we identify potential risks and devise strategies to mitigate them. It's like having a contingency plan for our journey. Finally, we develop a project plan outlining tasks, milestones, dependencies, and deliverables. This plan acts as a blueprint for the project, guiding us on every step of our journey. So, in essence, the requirements analysis and planning phases are all about understanding the what and the how of our software project. They set the foundation for all the subsequent phases of the SDLC, ensuring that we're not wandering aimlessly, but moving purposefully towards our goals. With a clear understanding of requirements and a solid plan in place, we move to the next phase. Once the plan is set, it's time to design the software. At this stage, the software begins to take shape, transitioning from a theoretical concept into a tangible blueprint. The design phase of the software development lifecycle is divided into two integral parts: architectural design and detailed design. The architectural design is where our software starts to get its backbone. Here, we define the overall structure and components of the software system. In other words, we map out the framework that holds all the elements of our software together. This is akin to the blueprint of a house, where we decide on the number of rooms, their placement, and how they all connect. The architectural design is a high-level view of the system. It is abstract and focuses more on the system structure rather than the minute details of its implementation. It answers questions like, what are the major components of the system? How do these components interact with each other? How does data flow through the system? Once we have a robust architectural design, we move to the detailed design phase. Here, we delve into the nitty-gritty details. We specify the internal logic, data structures, and algorithms needed to implement the functionality. It's like moving from the blueprint of the house to designing the individual rooms, deciding where the windows will go, the color of the walls, and the type of flooring. The detailed design is a lower-level view of the system. It provides the specifics of how each component will work and interact with others. It lays out the step-by-step procedures and algorithms to solve the problem at hand. It's the roadmap that developers will follow when they start coding. Design documents, diagrams, and prototypes are created to communicate the proposed solution. These artifacts serve as the guiding light for the development team, ensuring everyone is on the same page regarding how the software should look and function. Design in hand, we now move to the next phase, which is implementation. This is where the rubber meets the road, and our carefully crafted design starts becoming a reality. After design comes the implementation phase. This is the point where the rubber meets the road in the software development lifecycle. Here, our developers roll up their sleeves and start coding, taking each piece of the design and translating it into a language computers can understand. Every line of code is meticulously crafted according to the design specifications. This is like building a house, brick by brick, following an architect's blueprint. Each component is built individually, but with the whole structure in mind. This meticulous process ensures that all parts will fit together seamlessly in the final product. But coding isn't just about writing, it's also about testing. As each component is completed, unit tests are developed and executed. These tests are like quality control checks, confirming each component functions as intended before it becomes part of the larger system. Once the implementation phase is complete, we transition into the testing phase. Here, we put the software through its paces, examining it under various scenarios to ensure it behaves as expected. This phase is crucial to the success of any software project. It's the difference between launching a flawless application and releasing a product full of bugs. There are several types of testing, each with a specific purpose. Unit testing checks individual components, while integration testing ensures these components work well together. System testing verifies the entire system's functionality, and acceptance testing confirms the software meets the end user's needs. Finally, regression testing is performed to ensure that new changes have not adversely affected existing features. In this phase, we also identify and prioritize defects. Not all bugs are created equal. Some are minor annoyances, while others can bring the system to its knees. Identifying and prioritizing these defects helps us determine which ones to tackle first, ensuring the most critical issues are addressed promptly. With testing complete, we're ready for the next phase, deployment. This is when our software finally leaves the nest and enters the real world, ready to serve its purpose. But that's a story for another scene. Until then, happy coding and testing. Deployment is the phase where the software is prepared for release. Let's dive into the depths of the deployment phase. At this stage, our software is ready to be launched into the real world. However, before it takes off, there's a launchpad of activities that need to be executed. Installation, configuration, and data migration are the key elements of this stage. Installation is the process of placing the software into its operational environment. It's like moving into a new home, right? Configuration, on the other hand, ensures the software is tailored to fit its new environment perfectly. It's like arranging furniture in the new house to make it feel like home. Lastly, data migration is the process of transferring data from one system to another. It's like moving your belongings into the new house, ensuring nothing is left behind. Once the software is successfully deployed, we move into the maintenance phase. This is the longest phase of the SDLC and can often continue for years after the software has been deployed. It's the phase where the software lives, breathes, and evolves in the wild. In the maintenance phase, the software is monitored and supported to ensure its continuous reliability, performance, and security. Think of it as regular health checkups to ensure everything is functioning as intended. Alongside monitoring, the software is also nurtured with updates, patches, and enhancements as needed. User feedback, bug reports, and change requests play a critical role in this phase. They're like the vital signs, guiding the necessary adjustments to keep the software healthy and thriving. In essence, the maintenance phase is all about keeping the software in its best shape, addressing its needs, and allowing it to grow and adapt to meet evolving requirements. That concludes the SDLC, but it's important to remember that the process is iterative and focused on continuous improvement. The journey of software development is never-ending, and with each iteration, the software becomes better, stronger, and more attuned to the needs of its users. So we've walked through the phases of the software development life cycle. From gathering requirements to planning, from designing to implementing, from testing to deployment, and finally maintenance, we've seen how the SDLC structures the software development process in a systematic and orderly fashion. Each phase is crucial in its own right, feeding into the next and building upon the last. But what truly sets the SDLC apart is its iterative and incremental nature. This isn't a one-and-done deal, it's a cycle, a loop that's always turning. As we work in short cycles or sprints, we continuously deliver small increments of functionality, gather feedback, and adapt the product accordingly. It's a process of constant learning, improving, and refining. This is the essence of the software development lifecycle. It's not just about creating software, it's about creating the best software we possibly can, in the most efficient and effective way. Understanding the SDLC can help anyone involved in software development to better manage and execute their projects. Thanks for joining us on this journey through the software development life cycle.